Okay, so we can set up something called Mohrs circle to figure out the principal stresses on an element such as this. So the first thing we need to do is set up our axes where you've got your horizontal axis as your normal stress, and then you've got your vertical axis going downward as your shear stress, like so. Okay, now we need to find the center of the circle, and the center of the circle is given by sigma average, which is just going to be -30, okay, plus 0. Again, that's because I've got in one direction -30, the other direction is 0, okay, and that gives me -15. So the center of this guy is right here at -15, okay? Now I need to find the radius, okay, and the radius is given by the equation like this, where we have essentially our center given here squared and then plus, again, now my state of stress, shear stress is 12. Actually, it's going to be -12, but it doesn't matter because I'm squaring it anyway, like that. So the radius of this guy is 19.2. So I can think about what this will look like, meaning 19.2 in this direction, that's going to be, I'll have 4.2 over here, going 19.2 in the other direction over here. This will be like -34.2. Then I'll have 19.2 down like that, and then 19.2 up like this, and then we have a circle like that. That's Mohrs circle. Okay, now my current state of stress, okay, is at 0 and 30, right? So that is going to be this point right here. That's my state of stress, okay, where sigma equals 0 at that orientation there. And then what I do is I draw a line straight back like this over to here, okay, and back over here, this is where my -30 is occurring, right? This is 0, that's -30. Now, the height of this thing, okay, is right here, right? And this is where my -12 comes in, okay? Because that's my stress, my shear stress right there. So the height of that is -12 over here is also, this will be +12 over here. So that's my state of stress. Now, the thing is what are my principal stresses? Well, my maximum stresses are right here. This guy's going to be sigma 1. This guy's going to be sigma 2. Okay, and then this guy right here, this is my tau max. So once I draw that circle, I can easily find that. Now, if I want to find the position of it, okay, I need to figure out, okay, well, how do I have to rotate my line that I have drawn there for my state of stress to get to the position where it is? So for my principal stresses, I need to rotate down this much. And actually, there's a 2 in front of that. There's a 2p down that direction, okay? And then to get to my other orientation, right, where my maximum shear stress is, I rotate in the other direction, 2 sigma s. And notice, again, those are 90 degrees apart, right? They're right angles, but of course with that factor 2, that's that 45 degrees. That separates the principal stresses from the maximum shear stresses. Now I can just figure out using geometry, basically, where I have tangent to P then is basically opposite over adjacent, which is going to be 12 over 15, which gives me my shear orientation of -19.3 degrees. I can do the same thing with the maximum shear to find that angle, okay, and it's just going to be the flip of that, which is going to be 15 over 12 to get to that angle. Okay, which then gives me that shear angle, that max shear angle, to be 25.7 degrees. So this is just kind of a graphical way to figure out the orientation. So it just depends if you like to do things graphically or if you'd rather just grab those equations and kind of plug and chug and use them. This is a little bit more visual way to orient things like that. So again, you just find the center of the circle, the radius of the circle, okay? And then you can easily from that find the principal stresses and the shear stresses. To find the angle, you have to find your current state of stress and then do a little geometry to figure out what orientation those would be at. So yeah, and that's, you can just use this circle if that's easier for you to understand than the algebra.